At midnight, the copper wire should be asleep. Cold, quiet, obedient. So why does it feel like something is moving inside it? Like a hidden crowd you can't see, only sense? Germany, 1900. In a world lit by gas lamps and early electric glow, the smartest minds can make sparks jump, but they still can't explain what electricity truly is inside a metal. You can measure resistance, watch heat bloom along a filament, hear the faint hum of power in a line, yet the real engine remains invisible. A sealed door. And behind that door sits a physicist named Paul Drude. Picture the lab: polished brass instruments, glass tubes, the smell of warm insulation, notes inked in tight handwriting. Outside, cities are changing. Factories run longer, streets brighten. The future is arriving on wires. But every wire carries a question. Why does current flow so easily in some metals and stumble in others? Why does heat make conduction worse, when heat should make particles move more, not less? Drude doesn't chase the sparkle, he chases the mechanism. He proposes a bold idea that sounds almost too simple. Inside a metal, there are tiny charged particles, electrons, moving freely like a restless swarm. Not tied down to individual atoms, but roaming. And when you apply an electric field, you're not pushing electricity like water through a pipe. You're steering this hidden swarm into a drifting motion. But here's the twist, the part that makes it feel real. Those electrons don't glide forever. They crash. They ricochet off the vibrating lattice of atoms, off impurities, off anything in their path. Conduction isn't magic. It's a constant struggle between motion and collision. The metal becomes a stormy hallway, electrons trying to run in one direction while the walls keep punching them back. That's resistance. That's heat. That's why a wire warms like it's holding its breath. Then Drude points at something even stranger. Raise the temperature and the atoms vibrate harder. More chaos, more collisions, more resistance. Suddenly, the everyday behavior of metals snaps into focus like a blurry photo turning sharp. Not perfect, not complete, but unmistakably a door cracking open. And for the first time, you can feel the metal differently, not as a solid, dead thing, but as a crowded, microscopic city. A place where invisible runners sprint, collide, and spill their energy into warmth, all so your lamp can shine. Drude's theory won't be the final word. Later physics will deepen it, challenge it, refine it. But in 1900, he gives the world something priceless, a story of what's happening inside the silence, a way to imagine the unseen. If this invisible world sparked your curiosity, help the channel grow. Like, share, subscribe, and drop a comment. What's the most ordinary object you think is hiding the strangest secret?